Today we'll discuss what is the gradient divergence in curl in Brave, and before that what is the tail operator, because it's a very important operator which is concerned with gradient divergence in curl. So it is actually a differential operator, and it gives a variation of any quantity in a space in Cartesian coordinate like I cap curly by curly x, j cap curly by curly y, k cap curly by curly z. Okay, it is also known as parabola. It can be used to operate on a scalar quantity as well as on a vector. When it is operated on a scalar, like del vector u is maybe it's a potential, which is a scalar. So it can be operated on a vector as well, but it depends how it is operated with the help of dot or with the help of the cross. Now, what is a Laplacian operators? Laplacian operator. This is del vector dot del vector. It is a scalar quantity because dot product is a scalar product, and it becomes del square. Del into cos 0 is 1. So this is a del operator. Again the same. I cap dot I cap is 1. J cap dot J cap is 1, K cap dot K cap is 1. So the result becomes del square, which is a scalar quantity. Now what is a gradient of a scalar field? We are having a coordinate system, Cartesian coordinates. YZ plane, like our writing pad, it is in a YZ plane. X-axis is a perpendicular axis, perpendicular to the plane. We are having 2 points, point P and point Q. This is point Q. Okay. Point P having position vector r vector. P to Q, it is small displacement dr vector. Then by triangle law, this vector becomes the sum of this vector plus this vector. So from here to here it becomes r vector plus dr vector. Point P, is specified with xyz coordinates q, and there is a small increment dr vector. So in terms of xyz, coordinate becomes x plus dx, y plus dy, z plus dz. The quantity which is written with t means very small increment, infinitely small, you can say. Let we consider any quantity like a potential, which is a scalar quantity. Okay, it is a single valued and continuous. The potential having value at here V, and at here it is having value V plus dV. The small shift, small increase in potential at point Q. Now what is dV? dV is the small shift. What is dV? The small increment. dV is the small increment going from point P to point Q. We to find first of all how V changes only with respect to x. When we find how V only changes with respect to x, that called the partial derivative and is written with curl V upon curl x. And from here to here, the shift in x is dx. Then how V only changes with y, that is a partial change. Total change in y is, from here to here, this is dy. How V changes only with z, that is a partial change. Going from here to here, dz. So if I open this dot product, I cap dot I cap is 1. So curly V upon curly x into dx, like this one. J cap dot J cap is 1. Curly V upon curly y into dy is this one. K cap dot K cap is 1. This into dz, this one. So I can say this quantity can be written as like this. So this is, del V vector, which is called gradient V. This is called gradient V, this quantity. And this is dr vector. Okay, this one, dr vector. So dV change in V going from P to Q is gradient V dot the dr vector. Now dV is gradient V dot dr vector. Now the question is, because there is a dot product, so there will be a cos theta angle, because A vector dot B vector is AB cos theta. That means there should be some angle between gradient V and dr. Now we know very well dr is along this side. So let me say theta angle which is between the two. Let me mark that angle theta like this. This is theta, and we shown a direction of gradient V along this side with theta angle between the two. And there may be any angle theta. Theta may be from 0 to 90 degree. So theta, we written dV over dr as delta V magnitude cos theta. So if we say theta equals to 0, that means cos 0 is 1. cos 0 is 1, theta 0 means cos 0 is 1. Then this value will be maximum. This value will vary because of cos theta, and its value depend upon the cos theta. If theta is equal to 0, then that means this will have maximum value. So this is maximum value. What it is? The change in potential with respect to the R, potential gradient, and having maximum value. That is called that is the magnitude of gradient V. So what is the gradient V in magnitude? The change in V with R of maximum value. Now we learn what is the divergence of a vector field. So in Cartesian coordinate, del operator is like this, then dot between the two, and A vector is having in a space having components Ax, Ay, Az. So there is a dot product. So I cap dot I cap is 1. So divergence of vector field becomes so it is a scalar quantity because dot product is a scalar product. Now if the divergence is equals to 0, del dot A vector is equals to 0, then there may be some possibilities that either there is no A vector, there is no field. Second, if field is present, but there is no, the angle between the two is 90 degree between del vector and A vector. If angle is 90, then dot product becomes 0. So if del dot A is equals to 0, that means the solenoidal field, the A is called solenoidal. Now we have the second definition of the divergence of another definition. You know what is that? This quantity is the flux. Flux, emitting out. Flux diverging out divided by volume. Flux diverging per unit volume. but volume which you consider tends to zero should be infinitely small. Volume element should be infinitely small which you consider. So flux diverging per unit volume tends to zero. That's the divergence of A. So if the flux is diverging like this, a diverging flux. 10 मिनट बंद कर दे 10-15 मिनट वेट कर ला बाहर. If the flux is diverging, so this is positive quantity. If the flux is converging, convergence means like it's a converging flux like this, then what happen? It is opposite to the divergence. Then divergence of A becomes negative. Negative means it is not divergence, it is convergence. So if this is equals to 0, that means neither divergence nor convergence. No divergence, no convergence. Okay. And if this is equals to 0, one thing more, if this is a unit volume, this volume is very, very small, and whatever the flux, it is, whatever the flux it is out to this element, if the same flux in magnitude it enters, so net flux becomes 0. So then that means del dot A vector equals to 0. So in magnitude, whatever it exit, the same in magnitude it enters the volume element. So like in case of the magnetic field is not having a single pole, it always in a dipole, N and S. So in case of magnetic line of force like this, so if you consider the area element at here, so whatever it enters the flux, the same it leaves. So del vector dot B vector equals to 0. That implies in case of B vector there is no source or sink. Okay, that means del vector dot B vector equals to 0, and B vector is called solenoidal. This is the divergence. Like this arrow, they are moving outward, and vector field represents that this is a positive divergence. They're moving away from center. It starts moving away slowly, okay, because length of the arrow is very small from the center first of all, and as it gets away from the center it moves faster because now the length of the arrow is increasing, so the divergence magnitude is increasing as we move center to outward, okay. Now this is basically a convergence, the negative of the divergence, because this is the center and the arrow, they are moving inward. First of all, from the center, like here, they are of smaller magnitude, but as you are far away, they are bigger in length, larger in length. That means, okay, so this is flux. Now lastly we learn what is curl of a vector field. Curl of a vector field. It is defined as curl of a vector. This is del vector cross a vector. So this is called the curl of A. Okay, cross product between the two. You know how we get the resultant quantity. Okay, then we make a matrix I cap, j cap, k cap, components of del operator, components of A operator. Now just opening the bracket, open the bracket. So curl of the A vector is connected with the rotation. Okay, so rotation will be maximum if the angle between the two is 90 degree, between this and this. So del vector cross V vector determines the rotation of the fluid as explained. Just going the next page. So this is why it is called curl. It is explained in the next page. Okay. Direction of a rectangle having area delta S. This circulation divided by delta S, and the area was in a YZ plane and area was perpendicular to the x-axis. You know, why does the cross come in the curl? Already we explained del vector cross A vector. The value, the like A vector cross B vector, the cross product is always maximum when the angle between the two vectors is 90 degree. The curl is maximum if you are perpendicular to the direction of the field. So obviously for 90 degree, if like this example, to the flow of river, it is going to collect maximum force of water. Mean if the water is flowing like this, okay, and there is some difference in the water flow, like this velocity is less, more velocity, and still more velocity, still more velocity, and if you put a wooden stick like that at 90 degree, a torque will act on it and it will start rotating from this position to this position to this position to this position. Okay. A river is flowing, let us say, and it is flowing in a such a way that first of all at this point on the x-axis velocity is small, then velocity increases, then still further increases, and still more increases. So what happens if we put a small vector like black arrow, or let us say a wooden stick, maybe it's a wooden stick, in the flow of water, okay, and the flow of water is such that velocity is changing in the x direction, then that would gain the speed, along the x-axis, or we can view as if a force field shown that a wooden stick in the field will get forced in the x direction more and more as it moves. Okay. Now secondly, you observe this river flow, and then again notice what would happen if I place a stick in the flow at here, or at here, or at here, or at here, or at here. Just imagine yourself. Okay, you can put a stick in this position, in the position, and river is, like flowing along this direction. You put a stick, okay, in position 1. Naturally, you can see that velocity of water is more. Velocity of the water is more in the outward direction, away from the river bank. Okay, away it is, the velocity is more. Then towards, as compared to at here, near the bank. So it is simply to say the stick will come from this position to the position number 2, because a torque will act on it. A torque will act and it will settle in the position number 2. Okay, and then again the same happens after a certain seconds. The right side portion, mean outer portion, okay, of the river will be more rotated due to the high velocity of water in that direction, and will come in the position number 3, then position number 4. Okay, and next few seconds the stick will keep rotating until it comes in parallel direction with water. Okay, so this would happen with the rotating effect of river on the stick, which was firstly in perpendicular direction, then it will set in position 2, then position 3, then position 4, then position 5, then it is along. Now what do you learn from here? Think. When you put a wooden stick across the water, then it will naturally start rotating like this, like this. You know why? Because velocity of water in the center is maximum. Then velocity decreases like this, as well as along this side. Further decreases, still more or less. Okay, and ultimately theoretically it is 0 along the bank. Theoretically it is 0 along the bank. So due to the different velocity vectors, this rod will keep the rod will rotate and will settle ultimately along the river direction. Okay, now you know that rotation, like rotation of the stick, and one may be interested for finding out how much it will rotate. Okay, one thing is there, the more the velocity difference from here to here, between the center of the bank to the bank, more the velocity, the difference, the more the stick will rotate. Okay, this means that we can define a quantity which can give the magnitude of the rotation. More the magnitude, more the rotation, and less the magnitude, less the rotation. Mean that the velocity difference. Okay, and moreover this stick is rotating in the anti-clockwise direction along this side. Okay, Now you know the cross product of the two vectors give you the direction of rotation, and magnitude of the cross product is shown by a line perpendicular to the plane. More the magnitude of the rotation, and more we show by a length of a line perpendicular to the plane. Okay, and this is curl like anti-clockwise, and thumb shows the direction. Anti-clockwise rotation, thumb shows the direction. You curl your finger, and this curl effect of a vector, okay, is shown by the thumb. And if there is some force field, forces in it is in a space f vector, fx vector plus fy vector and fz vector, and you want to know how your object will be affected by the force, then you need to find the curl of the force field f vector. Okay,